Hello, AP Psych students. So at this point, you've probably figured out that I am out with COVID, unfortunately. So I will be quarantining up through Wednesday afternoon. I'm able to finally, hopefully, test out. Feeling much better. You guys kind of saw how crappy I was feeling, and I thought it was allergies, but apparently it was COVID. So that's neat. But anyways, I want to make sure that you guys do not fall behind just because I got sick. And so I have recorded today's lesson to make sure that we're keeping up with content. So to start off today's lesson, so regular warm-up, so you're going to complete questions 14 through 20 in your warm-up packet. So please take about 5 minutes right now to do that. You can pause this video, please. And you guys take about 5 minutes to complete those questions, and then we will go over them. Okay, so at this point, you should unpause and we are going to go over questions 14 through 20. So the occipital lobes contain, and the correct answer for this is A, the primary visual cortex. If you remember me kind of with my way to remember it, occipital, the oculus goggles, right? Eyes, oculus. Okay. So the occipital lobes are home to your vision. That's going to be important as today we are going over Unit 3, which talks all about your senses. So dopamine, norepinephrine, and acetylcholine are all. Correct answer for this would be neurotransmitters. E, neurotransmitters that excite or inhibit a neural signal across a synapse. Number 16, the mean will be higher than the median in any distribution that is. Okay, so first off, mean, average. So the average is going to be higher than the median. What's the median? It's the middle one, right? The middle in the order. So the mean will be higher than the median in any distribution that is. And the correct answer for this would be C, positively skewed. So if you're not sure what a positive skew is, let me show you real quick. Positive skew. So when we have a distribution that is positively skewed, so here we go, Google Images, beautiful, this is exactly what I wanted. So symmetrical, mean, median, and mode are all kind of stacked up in the middle. When you have a positive skew, we have this tail that goes out to the right, to the positive side. And then when it's a negative skew, we have this tail that goes out to the left, which is towards the negatives. You can think about it like that. So when we have a positive skew, the mean is going to be higher than the median and the mode. When we have a negative skew, the mean is going to be lower than the median and the mode. Okay? So 17, for most people, which of the following is an activity based in the right hemisphere of the brain? So the right and left hemisphere, remember, they're responsible for different things. The left hemisphere is especially important because that's where all of your language is. So the correct answer for this would not be D or E because D and E are happening in the left side of your brain. So the correct answer for number 17 is actually B, simple spatial reasoning. Spatial reasoning is definitely very much something that happens in the right side of your brain. Arithmetic reasoning happens in your left side of your brain, and the muscular control of your right hand happens from the left side of your brain. Remember, the left side controls the right side, and the right side controls the left side. Kind of confusing, but basically they do opposites. So you can do kind of process of elimination for number 17. Number 18, the place in the retina where the optic nerve exits the brain is called and that is the blind spot. It's the one part of your eye that actually doesn't have any cones or rods in order to see. And that's why your eye is constantly moving, is to kind of basically make up for that blind spot. Number 19, which of the following tasks will a patient struggle with the most after undergoing a hemispherectomy of the right cerebral lobes? So remember, a hemispherectomy is when they remove one hemisphere from your brain. So they remove half of your brain. This can only be done on the right cerebral hemisphere. Why? Because all of your language production and understanding is in the left side. So if we eliminate the left side of your brain, you are unable to have any communication. And so we just can't do that. So only the right side is the one that can be removed. So the correct answer for 19 is actually going to be D, writing a list of their favorite foods. Emotion is something that is held in the right hemisphere. So ranking something as your favorite would involve some sort of emotional connection to it, and that's something that you would struggle with right after undergoing a hemispherectomy. However, it's important to remember that when someone goes under hemispherectomy, so they remove half their brain, your brain rewires the other half of your brain to overtake the missing parts. So your brain, that's its plasticity. So brain plasticity means basically it's like able to rework and take over the parts that have been removed. Last but not least, number 20, Dr. Sayed announced that his psychology class that the results of the latest exam formed a perfect normal score. What percentage of the students scored within 1 standard deviation of the mean? So the correct answer for this would be A. So let me show you a typical bell curve. So when we have a typical bell curve, here we go, normal distribution. When we go plus or minus 1 standard deviation, so plus or minus 1 standard deviation, it's about 68% of the students. When we go plus or minus 2 standard deviation, it would be 95%. Plus or minus 3, it would be 99%. So you don't need to know how to calculate standard deviation, but when we're talking about a perfect bell curve, which is the only time that they would really ask about this on an exam. When we're talking perfect bell curve, the 3 statistics that you need to remember is plus or minus 1 is 68%, plus or minus 2 is about 96%, plus or minus 3 is 99%. So remember, standard deviation is how much it differs from the mean, from the average. So plus or minus 1 point or 1 percentage, depending on how many questions, are on the test. Okay, so if there's one of these that you do not understand or want me to explain more, I need you to circle it real big so that when I come back to school on Friday, we can talk about what you need to review, okay? So circle it real big if one of these don't make sense to you. All right, so next what you guys are going to be doing is you're going to be doing some heads up. So this is also going to be done again with your heads up from the must know AP Psych vocab. So at this point, you should take out your packet of AP Psych, must know AP Psych vocab. Each table, we only have 7 groupings, so 7 tables will get the packets of index cards. If we have 8 full tables now, which we shouldn't, move over to a table that has the cards. And the goal is each of you will take a turn with the stack of cards and you're going to pass them around. And the teammates should be putting out things to help you remember it. You can use your definitions on your sheet to help you today. However, come Friday, we are going to be doing a competition. You will not be able to use your packet to help you. So the more off packet you can get now, right, the more you can have memorized, the more you know now, the better, because you're not going to have that as like a support system on Friday. So pause me, spend about 20 to 25 minutes doing this, and then clean them up, put them back in their individual bags, and then we're going to come together to do some brain mapping. So pause me now. All right, so welcome back. Now we're going to do some brain mapping of units 3 and 4. So at any point, if you're starting to zone out or get really tired, make sure to advocate for your break. But we're going to get moving. So each of you should have out a blank piece of paper to do your brain mapping. I will be grading all of these brain mappings from units 1, 2, 3, 4, etc. I'm not going to be grading them like, oh my God, you missed this 1 point. I'm grading them like you were paying attention, you put in effort to actually start to map out this information and understand what we need to learn in AP Psych. Okay, so Unit 3 is what we're starting with. Unit 3 is sensation and perception. So it's all about the 5 senses. We're talking hearing, sound, perception. We're talking vision, in particular, like very important key terms, rods and cones. We're talking taste. We're talking smell. Remember, that's the one that skips the thalamus. It's the shortcut sense. And then we're also talking touch. So, principles of sensation and perception, kind of like the big ideas. So, sensation is the process of receiving information from our senses. And then the process of actually interpreting that information and turning it into something we understand is perception. We have a lot of sensations throughout the day. And what we make of them is what really matters. So sensations in and of themselves are important, but how we perceive them is the most important part of this. And this perception can be altered by learning, it can be altered by memory, it can be altered by all sorts of things. So the process basically is we have a stimulus, we have some sort of sensation, our sensory receptors get that sensation, so whether it's our eyes, our ears, our nose, whatever, they send a neural impulse to our brain, right? So the sensory neurons send that neural impulse to our interneurons in our brain and spinal cord, which then help us to perceive the sensation. So not every single sensation that we get on a day-to-day basis do we actually interpret, because it would be way too much if every single sensation in the world that we experienced we tried to perceive. We'd go into overload. So our brain basically makes a distinction using signal detection theory where we say, does this require a response? Yes or no? And then we either ignore the stimulus or we do something about it. So perception and sensation, you got to know the difference between the two. But then when we are taking in the world around us, we are getting these sensations, we are doing these perceptions, there's a few other things that are going on. So we have selective attention, what we focus on and what we notice, right? So I am very good at selective attention, partially because I grew up one of 5 kids. If I paid attention to everything that was going on in my house, every noise that happened, I would literally never get anything done. Selective inattention, what we are not focused on and what we do not notice. So selective inattention refers to our failure to notice parts of our environment when our attention is directed elsewhere. So basically, I can be really focused on like grading a piece of paper in front of me, and all of you are sitting in the classroom and I can see you theoretically, but I don't see, 2 of you passing notes to each other because I am not noticing that part of my environment because my attention is directed on my grading. This can lead to inattentional blindness and change blindness. If you are not sure what those 2 key terms are, then this would be a good time for you to write those down and study them. Also, here I'm going to take a really quick pause because I realized that I meant to say this at the beginning, but I didn't. When I am going over these concepts from units 3 and 4, if you have a question, write it down. Get out another piece of scrap paper or whatever, write down the question. I know as we're usually going over this, you guys have a bajillion questions, which I love. I think it's really important to ask questions to clarify concepts. Unfortunately, I'm not there to do that right now as they're popping into your brain. So if at some point something pops up into your brain and you're like, Ms. Piscini, you're explaining selective attention, but I have this clarifying question on what that is. Write down your clarifying question on a piece of paper and we're going to go over them. Okay? So, absolute threshold is the weakest amount of a stimulus you can detect. So, how much of that sensation do we need to actually detect? I can see a candle flame 30 miles away, but not 31 miles away on a perfectly clear night with no other light pollution. And the difference threshold is a little different. So this is how much of a difference between 2 stimuli do I need to notice that difference. Okay? So once again, this is review. So if there's something you do not know, I'm assuming that you know it, so ask it. Write it down. Okay, the eye. One of our 5 senses is sight. So the eye is a really important thing for you to know. So these are all the different parts of the eye. So if you're unfamiliar with the parts of the eye, I know that you guys went over that. Definitely go ahead and review it. But basically the way that the eye works is we have light from this candle, passes through the cornea and the pupil, and gets focused. so it gets focused in, and inverted, meaning flipped upside down by the lens. The light then lands over here on the retina, right? The retina is this part right here, where it begins the process of transduction, which is when it changes from a sensation into a neural impulse. And that neural impulse is sent down the optic nerve. The lens is not rigid. So think about it like, when you have an actual like fancy camera, right? And you are adjusting the lens and it goes like bigger to smaller to bigger to smaller. That is accommodation, which is changing the shape of that lens to focus on near or far objects. So we have accommodation in a few different ways in AP Psych. One of those ways is the lens accommodating for different things in order to focus better. So accommodating for it being the thing you're looking at being far away or close up. So the biggest thing is that it inverts, so it flips, that the lens is not rigid, it is constantly shifting to accommodate. This is the blind spot when actually, so on the retina are your cones and rods, and we're going to talk about those in just a second, but, excuse me, but the cones and rods stimulate, and then the neural impulse is sent out here, and where that neural impulse is sent out is actually this blind spot. So, rods, cones. Rods are black and white. Cones, see color. There we go. So they are right back here. Rods and cones are located on the retina. They are helping to understand and see this, which then this sensation turns into a neural impulse sent through sensory neurons down the optic nerve to the brain. Brain has the interneurons, and then it's perceived, right? So then it's interpreted. Okay, so then we have our hearing. Anatomy of the ear. So we have the outer ear, middle ear, and inner ear. Outer ear is where we have basically the sound waves coming in. They are focused and directed down through the auditory canal, where they then reach the middle ear, where we have the hammer, anvil, and stirrup. I just love those three names because it makes me think of like the Midwest, and they actually kind of like, it literally looks like a stirrup if any of you are horse people, and so it's a little bit easier for me to remember. And then it reaches the inner ear, where we have the semicircular canals, we have the cochlea, and this is where we do a lot of the interpreting of the sensation, right? So this is the sensation coming in, sensation starting to be interpreted here into actual neural impulses that are sent to the brain. Okay, so then this is when they're sent out the brain. So hearing loss happens in two parts, either in the middle ear or in the inner ear. So cochlear implants, if you've ever heard of those, that's when the cochlea is damaged, and people have an actual, so this is where the sensation is turned into a neural impulse. And so cochlear implants actually take over that job by turning sensations into electrical impulses. But if you have something like conductive hearing loss, which happens here, there's actually not you can use hearing aids, which then basically amplify the sound that's coming in to make it travel better, if you will. So then wavelengths and amplitudes. So wavelengths connect to frequencies. Amplitudes connect to sounds. So basically, short wavelengths, high-pitched sounds, long wavelengths, low-pitched sounds, great amplitude, so high waves are loud sounds, low waves are quiet sounds. And place theory, there's a specific location along the basilar membrane that will maximally respond to a particular frequency, thereby indicating the pitch of the brain. And frequency is basically how fast this is firing, tells us the pitch of the sound. So either there's two theories, basically where is the sound hitting in the ear, that will tell us the pitch, or how often is the impulse being sent, that will tell us. So that's the place theory and the frequency theory. So at high sound frequencies, signals are generated at specific locations. The brain then reads the pitch by reading where that signal is coming from. So they read the pitch by understanding the place where the neural signals are coming from, aka place theory. Frequency at low sound frequencies, hair cells along the basilar membrane send signals at whatever rate or frequency the sound is received. So lower sound frequencies will send the message less frequently. See what I did there? And then this one's not really as important. Volley principle at ultra high frequencies, hair receptor cells fire in succession, combining signals to reach higher firing rates. Not crazy important. So then we have taste, right? So why does food taste good? So basically, taste is not, honestly, if we're talking about of the most important senses for you to know about, taste isn't one of them for the AP exam. It is good to know, like, umami is protein, sour means potentially toxic, but really, honestly, not that important. Like, if you're going to prioritize in your brain, what do I need to know for the AP exam? Taste is not the sense you need to know. Taste buds are on your tongue. That's what you should know. Smell is a shortcut sense, so you should definitely, that's what you need to know about the smell, that it skips the thalamus and instead goes straight to the olfactory bulb. And that's why you can have some of the actually strongest memories connected to it, because it's not first filtered through the thalamus. So then we have this vestibular sense, which is basically sensing body position and movement. So we have kinesthesis and vestibular. So those are important, but once again, not as important as ear and eye. Okay? So summarizing the senses, this is a really good chart for you to reference. All of this we post on Google Classroom. This is super helpful for you to reference because to me, these are like key like bullet points. Like if you were to know anything about the senses, this chart is what you know. These are just a little bit of something to help you with remembering kind of like the different parts of the brain where these connect to. Okay, so that's Unit 3. Now would be a good time for you to pause, finish up your brain chart, maybe take a break, and then we'll come back for Unit 4. Also, write down any questions you have. Okay, welcome back to Unit 4. So we've gone over Unit 4 quite a lot in this class. So I'm really going to move very quickly because we've already gone over classical and operant conditioning twice. And so I think that you guys maybe have a pretty good idea of what's going on here. So we have classical conditioning, which is when we have a stimulus. It starts with an unconditioned stimulus that triggers a certain reaction and a neutral stimulus. So something that should trigger no reaction whatsoever. So for the dog, it's the bell. The unconditioned stimulus is the food. It creates an unconditioned response, which is the salivating. Then we ring the bell, show the food, dog salivates. Ring the bell, show the food, dog salivates. Then we ring the bell, there's no food, but all of a sudden the dog is salivating. So now that ringing of the bell is the conditioned stimulus, and the reaction is the conditioned response, that's salivating. Okay? So that process of figuring out that the bell connects to the food is known as acquisition. Okay? So they are acquiring that connection. Then, if you continue to ring the bell but not show any food, or like in my case, I tell my dog that he's going to get a treat, but then actually don't give him a treat because I just want him to get inside, then he might stop doing the behaviors. And that is called extinction. And then, say for a long time, I stop ringing the bell, or I stop saying I'm going to give him a treat, and then all of a sudden I ring the bell, or say I'm going to give you a treat. And all of a sudden there's a spontaneous recovery. The dog salivates again. For no reason, because it had been extinguished, but it's back. So remember, generalization and discrimination are also in this. So generalization would be that, like, say, okay, actually, I'm going to pause on that. Let's talk about little Albert because this is going to be a great example. So in the little Albert experiment, what you need to know was when that poor child that was subject to a very unethical experiment, which is when they repeatedly banged a really loud sound next to this poor baby Albert who saw the rabbit. And so then every time he saw the rabbit, he cried. He then, saw the rat, he cried. He then generalized that to anything that was white and furry or anything that was furry. That would be generalization. Okay? Discrimination would be when you're able to basically distinguish between multiple different stimuli that are similar, but only have that condition response to a certain particular version of it. So say we have a bell that rings really high-pitched and a bell that rings really low-pitched. Discrimination would be the dog understanding that the high-pitched bell brings the food and not the low-pitched bell. Okay, then we have operant conditioning, which is when we have reinforcement and punishment, positive and negative. So we basically have to ask the question whenever you're presented with a question on the AP exam that is operant conditioning. You are asking yourself, do we want this behavior to continue or do we want this behavior to stop? If we want it to be behavior to continue, it is reinforcement. If we want it to stop, it's punishment. Positive and negative literally are plus and minus, add or remove. Okay, so positive reinforcement would be adding something to increase a behavior. Negative reinforcement would be taking something away that was bothersome to encourage the behavior. Positive punishment would be adding something that's not good to decrease the behavior. Negative punishment would be taking away something that they liked in order to decrease the behavior. So, examples, right? So, positive reinforcement would be giving you money for doing your chores. We want that behavior to continue. We add something to make it continue. Negative reinforcement would be taking away one chore for every week that you do your chores. Boom. Take away something unattractive, right? Which is more chores, and that encourages the behavior. Positive punishment, adding an extra assignment if you try to turn something in late. I want to decrease you turning in that assignment late, so I add something unattractive, which is an extra assignment. Negative punishment, I take away your phone when you misbehave. Boom. Take away something you like in order to decrease the behavior. Schedules of reinforcement. So, fixed schedule, variable schedule. Basically, the questions you want to ask yourself, here we go. This is my little trick. Ask yourself, do you know the reinforcement is coming? Yes, it's fixed. No, it's variable. And is the reinforcement an amount of time? Time on the clock, it's an interval. Number or reps, it's a ratio. So, every 10 times would be an example of a fixed ratio. Every 10 months, fixed interval. Okay? These are the two questions you ask yourself on an AP exam. Okay, so that's the biggest thing between classical and operant conditioning. The classical and operant conditioning Hall of Famers, we have Pavlov, his classical conditioning, Pavlov and his dogs, and we have Skinner and his box with operant conditioning. These are little comparisons. The big thing with classical conditioning is it doesn't involve any cognitive decision making. It's like an automatic response. Operant conditioning, there is a cognitive aspect to it. You have to think, do I want this or do I not want this? So that's a really big difference. So involuntary and automatic versus voluntary and making decisions. Learning also, there are other things that factor into learning. Always whenever we look at a psych concept, we have to think about biological influences, psychological influences, and social cultural influences. So last but not least, there is observational learning, which is behavior that's learned when you watch and replicate others. So that would be the Bobo doll experiment. Remember in the Bobo doll experiment, the kids watched the parents punch the doll? So then when they went inside, they punched the doll. Children are sponges. I'm just going to say that right there. Children are sponges. They take in so much more than you could ever imagine. So they observe what's going on in the world around them, and then they recreate those behaviors. So then there's something called vicarious reinforcement. So we talked about reinforcement and punishment. Vicarious reinforcement is when you imitate a behavior based on someone else's reinforced behavior. So say I gave one of my students candy for turning in their assignment on time. You then might turn in your assignment on time because you want candy. I did not have to give you candy to encourage you to turn it in on time. You had to see somebody else get candy. So that was a vicarious reinforcement. So mirror neurons respond to your actions and the same actions of others. So basically, we mirror what other people are doing if we see that that is something that we can actually feasibly do. So that is observational learning. That's pretty much Unit 4. So this is obviously a very brief overview, meant to just kind of jog you on some of the key topics. So if there are some things that you have questions on, things that you need to review, now would be a great time for you to write down the questions you have for me, finish your chart, your brain map, and then if there is still time remaining in this class, I would highly, highly, highly suggest that you take some time to watch some of the YouTube videos that I will post on Google Classroom, or to take this time to really review some of the must-learn AP Psych vocab terms. Okay, so if you have any questions, please feel free to email me. Otherwise, I won't be back on Wednesday, but I will post another video for you guys to watch. And then on Friday, I will be back. So my sincerest apologies on leaving you a little bit high and dry due to being out for a week, but I will make sure that we make up all the time that we can. All right.